this and this, right? So that's what the labels are of the multiple types. But now weight is fine. Weight is a number. Machine learning has no issues with numbers. But what to do with the color? Because the color out there is a text. The color out there is a text, right? So now you can see what I'm saying is that transform means change that data, right? By using something called as one hot encoding. Now what is one hot encoding, right? One hot encoding is nothing but it is one of the ways of converting your text data into number, right? Means what? See, at the end of the data, it's either text, it is either voice, it is either image. It has to be converted to a number at the end of the day. If it is not getting converted to a number, then machine learning will not work on it, right? So if you see this data out here, what do we have? We have Apple and all this, right? So what it does is internally, what is one hot encoding? What happened to alt? It will take all this, right? And let me just show you the logic behind one hot encoding. So it will take this. So how many values we have? We have an apple, we have a banana, and we have an orange, and we have a mango, and we have a pear, right? So we have actually 5 distinct data out here, right? So what it does is it actually goes and puts an array to it. Remember, see at the end, an array, or you can say a vector, or you can say a tensor. Now I'm trying to put some words out there. See, any text, if you say Shiv, it has to be represented by a number, right? So a number, when it comes to a text, the numbers are normally like this: 1, 0, 0, 1, or it can be a matrix also. Like it can be 1. If it's a very big file out there, must be, it can be then something like this as well: 3, 4, 4. Right now, this becomes a kind of a matrix or a, right? Now, a group of numbers, either just a single value like this, 100, or either an array of value, right? Or either a matrix, right? All of these things is termed as tensor. I mean, you would have heard about TensorFlow. We'll talk about it later on. So now here also, he has to now use some logic and create a vector, create an array. I don't know whatever you say, whatever group of numbers he has to represent this data, right? So what he does is he actually says like this. He says that okay, so everyone out here will say is how much, like 0, 0, how much, 3, 4, 5, 5. So when we don't find a value, when it is not any one of them, right, then it is 0, 0, 0, 0. Now if it is an apple, one hot, he will make this as 1 bit. That is the only hot keyword out there, and other ones are all 0. And guys, I'm now, remember, this is the most simplest way I'm trying to make you understand how one hot encoding works, okay? The other one is, you will say it's a banana, so then this is hot out here, and this 0, 0, 0 represents banana. And the same way, the other one 0, 0, 1, 0, 0. So whichever thing he wants to represent, he will make them as a hot, right? So now this 1, 0, 0 in this context, in this data context, it is representing an apple. 0, 1, 0, 0, 0 represents a banana. This is termed as a one hot encoding. So what it does is it actually goes, it takes this color out here. Now this for the color, it does not, this is not the label, I'm sorry. Sorry guys, I give the example of a label. This is for the color, you will do it. Please understand. I'm sorry. See, because I'm saying that hot encode the color. Look at this. Color, fruit data color. Please understand. Right? I give the example of a fruit, but for color, whatever is the value, calculate it, right? And then he's saying, whatever is that encoded value, 0, 1, 0, right? Whatever, take that, and weight is a number. Take that, and that is a feature. So this is a label, and this is a feature. Previously, what was happening is we had everything as a number. That's why we don't have to specify all this on one hot encoding and all, right? See, remember, all of this is a pipeline. Remember that word flap, right? Features, labels, algorithm. So we are going to use SDCA out here, multi-class SDCA, right? And this is a pipeline. So it actually takes up a label, puts in a collection, it converts this fruit data color into a encoding, right? Remember, now there are other things also here. You have one hot encoding, you have bag of words, and a lot of things are out there, right? But one hot encoding is good for this when you have just one text, right? It is features and the features, right? Flap, remember that flap, right? And we are trying with SDCA. So is there any other thing out there? SDCA, look at it, image classification is also there. A lot of other algorithms is there, but we'll choose SDCA for now. Try with other algorithms. And we are saying that whatever you get right, please map it to the predicted value. Now, what is this predicted label, right? See, this is the fruit data you are giving as an input to input, and the prediction now will come in another class which is called predicted label. Look at it. You have to have a class to receive it, because now you have to receive a text, right? See, previously we were receiving a number, predicted. That's why it was saying predicted premium. But now we are receiving a text, right? Now here this is not a score, so that's why it is not a score. See, when you mark something as a score, you can say this also as a score. But when you mark something as a score, right? Score means it can have R square, RMSE, averages. It can sometimes have metrics inside it. But here now we are having actual data, so that's why I will not say this is a score. But what we are saying in the last line is, what we are saying is, we are saying that whatever is that thing, put it in the predicted label, right? So we are saying tell the fruit in the fruit data now. For example, we are providing 110 and LO. So now what he will do is that LO internally he will convert into something like 0, 1, 0, 0, right? And now you can easily look up that it's a number, right? It's a tensor, so you can easily do a lookup out there. So that's multi-class, right? Also, let us see. Ooh, what happened? Can't bind with it. You can see there is some error out there. That's a white stick. Can't bind iData view label for type boolean. Yeah. See, remember, I had this over here is a predicted label. Look at it. This one here. Go to definition. This one here, I have given it as a predicted label, but at this moment when I'm doing a binary classification, a binary regression, right, it is going to be only true and false. So actually I should be only having this and not this, right? So if I say it is an apple or not, that's what is the output. So in logistic regression, that's why it was taking so much time. So I'll say that the result is it an apple or not? And this is where I'm expecting him to give my label. So my label is apple or not, right? So that's why it was taking time. I was just wondering why. I hope everybody is understanding. What was happening is that in case of binary, right, in case of the, yeah, now this also we have to change afterwards, we'll change it for now. Just, I can keep keep two columns as well. Still that SDCA takes time. Okay. Guys, please run this code later on right after the class, because in the time of the class what happens is sometimes I would be running very huge data out there, and it would take some time out there, right? So I don't know. I hope that this time it should give a proper data out there. Yeah. Any questions, guys? So what we looked today into, right? We looked into binary classification and we looked into multi-class classification. When it comes to multi-class classification, we are talking about bag of words, we are talking about one hot encoding, we are talking about NLP and so on, right? So must be until this runs, right, we can look at the questions as well. It's a new category of algorithm. So see how your mindset should be now, like look at it. So I'll just put it here. Uh, what is the situation? The situation is I want to find connection between two numerical values, right? Numerical values. So then that is you're talking about regression. I'll create a mind map later on. You'll say no, I just want true and false. Sentiment is good or bad, right? Then we are talking about binary classification, like just true and false. True and false, 1 and 0, negative and positive, male and female, but it has to be only 1 and -1, why not? So it has to be only two values. then we are talking about binary classification. But the time it comes now, sometimes you'll say no, like it's not just true and false. We are actually talking about gold, silver, good customer, bad customer, and something, right? Medium, low, and average, and so on. Then we are talking about multi-class. So if you have more than two values, and when more than two values come into picture, text comes into picture. Text comes into picture, and when text comes into picture, we are talking about one hot encoding, right? And this is where we have the multi-class classification. So these are the three things we have covered. Remember, when you say regression, inside that again, SDCA is there, understand it, right? Light GBM is there. These are all algorithms of it, right? And so on, and which we have looked into. So this is the main family, and this is the sub. This is the main, and this is the actual algorithm. Something is not good out here. We'll see why. Check out. Okay. So guys, let us see at the let us look at questions out there. Encoding is stored in memory. Encoding is stored in memory, but remember that what happens now when encoding is stored in memory. Sometimes you'd like to store it in SQL Server also. Now I'm coming to the main point, guys. The main thing. See, vector lookup. The main crux of machine learning would be vector lookup. We'll talk about that one architecture which is used in almost 60-70% project, which is called as RAG. Right? We'll talk about RAG as we move ahead. So if you look at SQL Server supports vector lookup. So now it is happening in memory, but SQL Server also supports vector. Vector means tensor. So that's going to be that's very interesting part of it. And I don't know how many people vectors in SQL Server. So that is a vector data type we have in SQL Server, and we can go and we can store. Actual. You can see that, so we can store a proper vector like 0, 1, 0, a full matrix, right? And there it is. You can see that's a vector. Now this makes SQL Server very interesting, right? You know why? Think about, you have a document, you convert that document into a vector, into a tensor, and you store it. And then when you look up, and then somebody says, okay, I want to go and search in the document, right? You will take his text, convert into a vector. Both the vectors you will compare, and you will try to find out the cosine, nearness, or you will try to find out how near these two vectors are. See, only maths will work. Even text, like when you say that my name is Shiv, name is Shiv. So what you will do, you will say, okay, my name is Shiv, the vector is like 0, 1, 0, 0, 1, and say, okay, name is Shiv is like 1, 0. Oh, there's only one bit difference. So these two data look to be very same. So remember, the tensor lookup, the vector lookup, whatever you want to say, matrix lookup, right? This group of number lookups is a very strong part of the whole machine learning. So we'll have a look into that, bag of words and so on. Okay, there it is. You can see false. Yeah, so it's false. You can see SDC algorithm. Remember I said SDC algorithm streams. It takes one thing. It's very artistic. It takes one value, then says, okay, this is near to this value. That's why it was taking time. So that is one. Second, the same thing we can run now by also for this, right? For multi-class, right? So multi-class, again the same thing, but remember, I should have created two classes out there. But so in case of multi-class, what we have to do here is remember that the output of the data of the multi-class, is not true and false. Must be I can keep. Actually, when I kept both the values, it was giving me a problem. That's why I had to flip. So now here, I'm seeing predicted label, and that's it. That other one can crash now. I'll figure out, guys. Please, if somebody can figure out, because this is how I think something was crashing. That's why I kept it. Okay, let me see. So now here, what we are doing? Look at the multi-class. In the multi-class, we are again feeding him data, and I'm telling him that 110 and LO, 110 and LO. So as per this data, 110 and LO is a banana. It should actually give me out a banana out. So yeah, we'll see. Let's look at the questions. And must be we can enable the mics now. In Explore, we can if ML is needed or not. Sometimes it could be done without ML. See, exploratory phase, right? Exploratory phase means you are understand the exploratory phase. Exploratory phase. I'm taking Arpan's question. Exploratory kind of algorithms, right? Are algorithms which are like how do I say it? Exploratory means like clustering. See, there are two types of machine learning, right? One is that you know the data, like structured machine learning, right? Another one is that you want to go and tell that, okay, go and now explore. Then we are talking about some algorithm like clustering. In case of clustering, what happens? Let's say you have a lot of data given, right? And it says that, example, it says that the age of the customer, what time he comes, and what he buys. Okay, and you get huge amount of data. Now what he can do is that he can go and he can start exploring this data, right, by using clustering algorithm. He'll say that, okay, I find that teens, actually go and shop in the afternoon, and then mostly buy
ಮೀಟಿಂಗ್ ಇದೆ
shoes and jackets and so on. One
ರೆಕಾರ್ಡ್
group of
ಮಾಡ್ತಾ
people
ಇದ್ದೀನಿ.
he has formed. Then he says old people
ಐದು
come in the
ಚಾಪ್ಟರ್
evening
ಓದಿದ್ದೀನಿ,
and
ಎಲ್ಲದರಲ್ಲೂ
they buy
ಹತ್ತು ಕ್ವಶನ್. ಸ್ವಲ್ಪ ಧ್ಯಾನ
something,
ನಿಮಿಷ
like
ರೆಸ್ಟ್.
some holy books or
3
so on. That is
minutes.
this example. So basically what he does is that he will actually go and create small clusters of algorithms. So that is called as exploration. Okay. So exploration, for that, Arpan, the algorithm should be exploratory. Yeah? If the algorithm is not exploratory, like linear regression is not an exploratory algorithm. Yeah, Piyush will go, don't worry. How many total categories we can have in ML.net? See, for now, whatever three categories I've talked now, look into that three categories. Don't look into other categories. I will add them. So, no, so how do you practice this after the class, right? See, don't copy paste it, I would suggest. If you look at see why I'm now copy pasting now, because these all syntaxes are almost same. At this moment, the syntaxes are almost same. That's why I'm copy pasting it. But I would suggest like this: take up a sample data, and here's what I would suggest if you want to really do it. And this is our cohort now. We have the Nifty 50 data out here, which I pasted. I think I need one more entry out here, one more entry of the December and the January data. Somebody please paste that data out here of the Nifty. This is the closing of the Nifty, and try to find out that when will Nifty close in the February now. So December and I think I took it from Yahoo or somewhere. I don't remember. I took it from How Copy from NSC. I think. So put this one and try to now think. Very simple now. Look at this again. Here the relationship between date and number. Try this out. So how to practice? My codes out here only will give you a roadmap saying, okay, this is this is exploratory, this is this, right? But it won't, if you want to actually, until you don't take up a situation, nothing will happen. So take up a data, have a clean data, right? Why I took Nifty data? Because Nifty data is almost clean out there, right? So try this out, and I'm sure that whatever I've taught out here now, almost all the mathematical regression, you have to go through it. You will use SDCA, then you will try with linear, it will not work, right? A lot of things happen out there. So please give a try, and remember that this is a cohort, and this cohort I will take in one of the lectures later on. So don't copy paste, yes. So dear sir, let me know how our program got failed due to invalid parameter of prediction. Right? So it actually showed up. It showed up in my code. That's banana is predicted. So it actually showed up in my code, Abu. It told me that the data type is mismatching. So when it ran, right, it told that the data is true and false, and your is a text. So you can know from the console only. Tensor, will look into Tensor, guys. See, what I've done is, first thing, we have separate lectures for TensorFlow. So for Tensor, I'm telling you what is my plan. We can enable the mics now. Please, if anybody wants to speak, raise your hand, and I will enable the mics. I don't know if the mics are enabled. You unmute and you can speak, because we have 10 minutes. So very quickly, see, for vector, right, guys, what I'm planning must be for the next class we will do vector. Nipin wants to.
Yes, sir. So,
Yeah,
sir, what I was trying to understand here on the tensor, when you map that, I will take color only. When you map that color to the main instances, like it was repeating data, but we took the individual data, and then we mapped it to a binary value where we were getting like the one hot encoding we took. But if we backtrace it, so one instance, how it will map to the original one? That is what I am just confused.
Okay. So I'll answer here. So what you are saying is that, for example, now example this is here. Shiv is a trainer, right? This is a vector we have here. Example, please correct me. Now I get here, let's say Raju is a trainer. Okay. Now Raju is a trainer, vector will not map like this. It will map, must be something 1, 1. I'm just giving it.
Sir, if possible, take the other example that you put in the notepad, sir, if possible.
Notepad, yeah, the one which is, okay.
Yeah,
So I think let me do that. So let's say red, green. Okay, I'll do that. Red, green, yellow, right? Red, green, and blue. Okay, RGB. So we say that, okay, we say when it is red, it is 0, 0, 0, right? When it is green, it is 0, 1, 0, and when it is 0, 0, 1, right?
Yeah.
Now, from the other end, now somebody says, okay, this data is blue. So in this context, blue is 0, 0, 1. Please understand this. In this context means I will be using the same algorithm to create my blue again. Are we getting it?
Yes, sir. This is clear, sir. But, sir, in the actual data that we have many instances of red, we have many instances of green, and we have many instances of blue. Now, this blue that we are creating as a one hot encoding, how it will map to that particular blue which is being chosen? That is what I am thinking, or I am thinking something wrong there.
No, see, he will not only map the blue, he will also map the weight. Okay. So it's not only the blue. If you see here, there are two features, right? Can you see? So it will map both of them and it will find the nearest value. Are you getting it? It will also map the weight. It is not exactly the blue and blue.
Sir, if you go to the data that you had here in the Visual Studio, the data that we have.
See, look at this. He will, let's say,
this one.
Let's say now the red he can know, but now this value will be something like between, let's say 120 it is. I'm saying, So then he will say, okay, which is the nearest one, right? The nearest one. Let's say that if it is red and it is 200, then he will get confused. He will say, don't know what is happening, right? Apple will be false or something else. So he will try to get the nearest value.
Okay.
Also, I can see one question. Okay, please unmute, guys. Support whoever is raising hand, please unmute them one by one.
That is Ranjit.
Yes.
So you said that in SQL Server there is a data type called vector, right? So when you give the input, I understand this whole thing, the text converted into numbers, which is a vector lookup. So why do we have to save it in the SQL Server? Why can't we just, like, if your model is in cloud or on OpenAI, where do you see the importance of storing the vector in the SQL database?
See, sometimes, like you have some data which you don't want to give it to OpenAI because of security reasons, or you don't want to pay money to OpenAI, or your lookup is very simple. Are you getting me? Then why you need that whole LLM out there? So at that time, people use a simple lookup, they use a simple algorithm, and they manage their own machine learning.
Awesome.
So, but I can use, but I can see message in private. No, but if you use LLM, you have to pay money not to OpenAI. Simple, like Shiv is a trainer and you want to compare trainer is Shiv. How much near these two vectors are you? You only want to compare that. For that, why do you need machine learning? Simple ASP.NET, simple ML.NET, done. You don't need Python in this, right? Yes, it will sign up. Why not? So it's with speed also. See, we'll talk about RAG. At that time, this will become more clear, right? Also, there is one question which is very interesting out here, which says that how do you find out the difference between two vectors? I'll just answer that. I will take up questions again. See, in maths, to find the difference between two vectors, don't go into maths again. Don't go into maths. There are two ways to do it. One is called as the cosine similarity. Another one is called the Euclidean distance. Right? I can't even spell it. My maths is very weak, I'll tell you. But I'll tell you what are these two, right? These two actually take up a vector. For example, even if you look at SQL Server also, whenever they will do a select out here, let's see, they should have a select which says how near is their Euclidean distance or how far is their cosine. So, they must give some vector functions out there which says that search, yeah, if I want to go and do a search, yeah, look at the exact nearest neighbor, then he must be doing some kind of, look at that vector distance. You can see vector distance, he's saying use the cosine way of finding, right? So what are these two? Let us understand it. See, Euclidean distance is nothing but it's the actual distance. If you say that how far is this object from him, it can be kilometers, it can be meters, right? Like that. While when you talk about this cosine, right, it is an angle. It says that it's not from the perspective of the distance, right? Try to visualize, guys. Now you have to only visualize. Binary means like that, and this means like that. Because if you go into maths, you won't be able to do machine learning projects, right? So cosine means he'll say that okay, this is 90 degree away from it, or this is 0 degree means it is a very good, right? So when you're talking about angular distance, right? Then you're talking about cosine. When you're talking about the distance, right? Then you're talking about Euclidean, right? Now which one is good? That depends on the data out there. But when it comes to text, I like cosine a lot because cosine gives, especially textual. I want to get that this feeling and these feelings are same or not. Then I will use the cosine. So we'll see both of them. But to answer your question very, in a very proper way, between two vectors, you find the difference by using cosine or Euclidean. And any vector database out there, either SQL Server, either Oracle, or any machine learning database, right? If they are supporting vector, that means that they would be supporting both of these functions in their query, right? Yeah, please unmute. Yes, I'll also see. Yeah.
Sir, good evening. I have a question. Sir, is it audible?
Yes.
Sir, actually, today I was doing one exercise. So, when to convert this text to token, I am using feature text. And now you have used this one hot key encoding. So, what is basically the difference between these two?
Yeah, so very good question. I'll take this. Remember, a lot of things ahead, right? But let me take it up. What happens now? This is very simple. One hot encoding is like just very simple. But if I tell you that here is a whole document, and now go and find out the meaning of this document, then you will need bag of words. Then you will need TF IDF. Then you will need word embedding. That feature text is that. That feature text is more advanced. We'll talk about this. This is the next lecture on bag of words and textual and NLP. So when it comes to textual, the one hot encoding is a very simplest way when you have just 10, 15 values, enum type kind of data. But when you're talking about text, then that feature is for that. We'll come to this later on. I hope that answered your question. I'll take one question from the text. What generates these vectors? Yeah, what generates this vector? See, generates the vector, the algorithm. One hot encoding said it is a way of how you represent your values, 0, 1, 0. So that is the algorithm of it. One hot encoding is every word becomes a unique 0 and 1 vector. So it is a way of doing it. Yeah, go ahead with your question. Yes.
ಇವಾಗ ಇಂಗ್ಲಿಷ್ ಲಿಟರೇಚರ್ ನೋಡ್ಸ್ಬೇಕು ಮೊಬೈಲ್ ಕೊಡ್ತೀಯಾ?
Yeah. Please
ಒಂದು ಅರ್ಧ ಗಂಟೆ
unmute,
ಮುಗೀತು.
because now I'm not in control of the
ಕಂಪ್ಯೂಟರ್ ಓದ್ತಾರೆ.
this one.
ಕಂಪ್ಯೂಟರ್
That
ಓದ್ತಾರೆ.
is the model remember in memory. At this moment, in memory. At this moment.
Oh. Okay, thank you, sir.
Yeah. Go ahead.
No, I was just asking about you shown us regarding this red, blue colors, right? I was asking about when we convert into vectors, each and every string, right? How does that model remember, like red represent this, blue represent this, and other string represent this? So when we compare, how does it, where it remembers? Does it have any kind of API that does
No,
that?
at this moment, this is in memory. It's completely
Okay.
in memory. If you want to store it later into SQL Server, right, then
Yeah.
that will be into SQL Server. At this moment, it is in memory. If you look at this, we said that take this and put it into this color encoded. Then this is where it actually.
Okay. Yeah. Got it. Yeah. Thank you, sir.
Actually, ML.NET, right, this API is very tough to understand, I'll tell you. They made a grave mistake. Somebody has to go and write an open source over this and make it very easy. You don't have to do this. But I say here, what to do. And that's why now, like, people don't, I've done a lot of projects in ML.NET. Some of the projects I did not use Python. Wherever I needed Python, I went to Python. And it worked like a charm through ASP.NET MVC Core, looking up a vector, at the background creating a model. It's working perfectly well. So I feel only thing is, there are no tutorials. And when a .NET that is so tough, right? You have to know concatenate means this plus this. You have to know what is a one hot encoding. If you look at Python, right, it is not like that. It is a dot fit. That's it. He will figure out the y and x. So that's a problem here. We'll do it in the class. Yeah.
Sir, for every input, we are executing this pipeline. So, is there any way to restrict that?
No, so very good. Yeah. See, this lab 7 I missed out. So what you can do is that you can save the model. Can you see here? You can save the model. You can serialize and save it out here, and then you can load the model. We'll do it in the next tomorrow class, and you can also go and load the model out here. Means after that you can let us say you store the model as .zip. You can load it and then query it.
Sir, I have another question. It's regarding this. In the beginning, you showed us the train data and test data, right? Let's say I've got an array of data like 200 number of records, right? So when we split that to 0.2%, it takes you 80% of the data and 20% train data and 20% is your test data, right?
Yes.
So does it perform it randomly, or is it always going to take that? How does it identify that 20%? Is it constant always, or is it going to change when we run it?
No, so this see for now whatever setting I have done, it will take the last of the 20%. Okay, but there are settings out here. Now I don't remember those settings. Those settings can help you to take random data, or like for example weighted. I don't remember weighted means. For example, you will say that if you have already taken this as a test data, don't take it again.
Oh, okay. Yeah, we'll see that.
Yeah. Since you can see sampling, there is something how to sample. So yeah, there are the way you can sample the data. So you can say take it randomly, or take it the data which is not there, or take data which is not a part of your main learning. So those kind of things you can set it out there.
Oh, okay.
But now it will take the last 20%. Now it will take the last
20% of the rows. Okay.
How strings map to vectors? So Hemant, I've already said that if you use one hot encoding as the algorithm, it will use one hot encoding. So the strings they map to the vector in a collection at the end of the day. But two vectors are compared by using cosine and angles, right? Cosine and the Euclidean distance. So okay guys, so I can take up the last question. Yes, go ahead. Yes, I know that. Yeah. Please go ahead. I can see a lot of people asking questions. We can take up 2-3 questions. Yes. Response support, please unmute.
Sir, we have the cluster, the lab example, right? So in that cluster, I see that the feature we mentioned, we don't have any label mentioned there. What actually the cluster is doing?
No, so here you are saying about, we'll see that lab tomorrow, but just to answer your question. So you are saying that this thing out here, it is actually saying, it is just saying go and find out the cluster, right? So can you see here, I'm specifying 3 clusters. So you will just go and find out age, spending, and so I'm saying here 3 clusters. So can you see the feature here, age and spending?
Yeah.
So he will try to form 3 sections for 10 to 15 years spending 1,000 rupees, 20 to 40 years spending 4,000 rupees, and 40 to 70 years spending. So 3 clusters he will try to find out by looking at age and spending.
Is it segmenting?
Yeah, it's actually classifying. That's what it says. Clustering.
Okay.
We'll see that tomorrow, guys. Don't worry.
Okay. Yeah.
Yes.
Sir, I have one question. For
ಅಡಿಗೆ ಪೈಲೆ ಆಲ್ರೆಡಿ ಆಗಿದೆ ಸುಮ್ಮನೆ
based on
ಹೋಗಿ ಕಂಪ್ಯೂಟರ್ ಓದ್ತಾರೆ ಬಂದ
by trying to determine if there's a credit card fraud data I am trying to do or some kind of a insurance data. So how do I design that inference? Like should it be asynchronous? Should it be serverless? That kind of a thing, right?
No, so see, how the design is, it will depend. I know that this answer is very bad, depend, right? The first thing is like, where are you hosting it? Okay, if you are saying that it is going to be in my, like for example, we have the hospital management system. So there we say that if you have this kind of patient, as soon as he comes in, we come to know he will get admitted or not. Okay, example I'm saying. Now for that we have, now in that case, the way we have, the first thing is, remember that whenever you are designing any model, you have to have a very good understanding of your data. There is no excuse for that, right? For example, if you are seeing credit card fraud, it can be, you would check for a geography, you would check for a time, you will check for IP address and all that, right? So the design, the training of the data, you have to sit with the end user, people who are working in that fraud department, you have to tell him that how do you think, right? And there, that model, that's where the requirement has to be captured very nicely. If the mistake is happening in the requirement, your machine learning algorithm will not perform, right? Second, like how you are going to host it, right? Is it going to be serverless or not? That depends. If you're going to host it in-house, right? The model is lying on your server out there. Like let's say I have my own model, I can save it, right, and load it. Then you don't have to look at serverless or not, right? But now if you're saying no, like I'm going to host it on cloud and people are going to use it, pay, so then it will be serverless. So the designing part, the infrastructure part, the designing part completely depends. Okay, so guys, we'll stop here today. I know that a lot of questions are there. I will take last one. Biswajit, yes. Let's take Biswajit's question and we'll end. Yes. Sure, yeah.
Hello, sir.
Yes,
Sir, I have a use case like I have a project. In contents, like we have details about the project, like what it does and what it will be exposed, right? So there are a lot of consumers who don't want to learn. Coming to me, they want something agentic type of things, like they need want like for these features, what API I need to use, or what is your project details, all these things, right? So my use case will be like, now instead of using the LLM, so how I can use my own model, all these things, like just use case if you can just explain me, right, it will be easy for me.
No, so if your question is that I don't want to use any LLM, right, and I want to do it myself, then you have to know. Then you have to know all the algorithms, right? Which one is supporting? Let 2 or 3 lectures happen, Biswajit, you'll get the answer of it, right?
Okay.
Because like somebody saying, I'm seeing features here, you are doing one hot encoding, so we are coming to that. So as you go 3-4 lectures ahead, you will find that, oh, like I have to use that, for vector lookup, SQL Server, and then I have to also use Python because there is TensorFlow out there. I have to expose. So you will find that when you're coming with the solutioning, right, it can be using your own LLM, not own LLM. I'm like, it can be using some LLM called as Llama, right, which is free. And they say, no, we are not going to give to Llama also. Who knows, Llama is exporting tomorrow to somewhere else. Then you are going to go and use your own ML.NET or Python. Put that thing in your computer out there. Load that model from in memory with ONX. So remember, depending, somebody who is paying money can use OpenAI and be happy. Somebody who says, I want to only predict this, then he is happy only with the one hot encoding. So let the lectures go by, you will come to know. The bigger picture will come into picture, yeah.
Okay. And another thing like, please. And another thing like, currently I'm working on a project like, the automation of email systems, like in corporate, like we are getting a lot of emails and there is nobody to reply on time. So what we are doing, like we are getting the email and every email, right? We are trying to understand the intent of the email. So I'm reading the email and sending to LLM, and LLM is giving the intention of the emails, what user is asking, right? So how the LLM is understanding, like from my data, what is my intention? So that concept I just want to know. Right?
Yeah. So this is where we are going to come to the bag of words. See, today's text algorithm, one hot encoding was like a ABC. So This bag of words is what will help you to identify. The word embeddings are there. We'll come to this, these topics are ahead, right?
Correct. Okay. Thank you.
Yeah, don't worry. Okay, guys, thank you very much. And thanks a lot. Our WhatsApp groups are open. Vishal is there. Sagar sir is there, right? Next week onwards, every Sunday, we will start with Python also, Python fundamentals. So Sagar sir will help us to go through the basics of Python, and I'll be there, teaching the topics out there, and then we'll see how that can be implemented in Python as well. Okay. Thank you. Thanks a lot. Thank you.
Thank you, sir.
The recording has stopped.
ಮುಗೀತು. ಟ್ರೈನಿಂಗ್ ಮುಗೀತು, ರೆಕಾರ್ಡಿಂಗ್ ಸ್ಟಾಪ್ ಆಯಿತು. ಇಷ್ಟೊಂದಿದೆ, ಏನೂ ಅರ್ಥನೇ ಆಗ್ತಾಯಿಲ್ಲ. ವಾಟ್ ಈಸ್ ದಿಸ್ ಅಂತ. Dear highlighted announcement of launch a toddler swimming program at Kalapa Aquatic Center. Thoughtful design, young child begin their swimming journey. Toddler swimming. Ayya. Idenappa idu. Shuprasad. Naukari unlock your potential. Job might be missed this week. What is this? What is the difference between discover substitution principle and dependency inversion? If you hesitate even for the second, you are not alone. In today's webinar, I asked 1,000+ developers these questions. More than 80% have got it wrong. Some confused it was interface segregation, Liskova substitution principle, and dependency inversion. Interface segregation, some gave the dependency inversion answer and some just stayed silent. This is what happens in the real interviews. You know the concept, but you are read about it, maybe even used it unknowingly, but when the interviewers ask, your mind goes blank. The words don't come out of right. And then someone who knows less than you but articulate better the guest of job. Okay. Interview preparations, solid principles, solid questions. Okay. ಅಯ್ಯೋ, ಎಷ್ಟು ಕಲಿಯೋದೋ, ಏನು ಕಲಿಯೋದೋ, ಏನು ಮಾಡೋದು, ಸಾಕು ಇದೆಲ್ಲ ಮಾಡಿ ಮುಗಿಸ್ಬಿಟ್ಟು. What do you mean by, what is this? Question and answers. So, there is 2 parts. Question and answers. So, ಯಾವುದಿದೆ ಸಿಲೆಬಸ್ಸಲ್ಲಿ? ಡಿಸೈನ್. ಓಕೆ. AIML C# developers training recordings ongoing. Introduction to C#, MLO, OLS, SDCA, OLC Square, using understanding the feature engineering, online algorithm performance and factors in linear seasons and nonlinear, machine learning algorithm classifications, understanding NLP, using embedding and transformation to understand the relationship context, GPT, but ChatGPT and using prompt, AML training revisions. Okay, Python. Okay, ಇಷ್ಟೊಂದು ಇದೆಲ್ಲ ಓದ್ಕೋಬೇಕು. ಲೈವ್ ಟ್ರೈನಿಂಗ್. ಓಕೆ, ಅಜೂರ್ ಬೇಸಿಕ್, ಅಡ್ವಾನ್ಸ್ ಟ್ರೈನಿಂಗು ಇದು ಬೇರೆ ಇದೆ. ಇದೆಲ್ಲ ಮುಗಿಸ್ಕೊಂಡ್ರೆ ನೆಕ್ಸ್ಟ್ ಇಂಟರ್ವ್ಯೂಸ್ ಅಟೆಂಡ್ ಮಾಡೋದಕ್ಕೆ ಈಸಿ ಆಗುತ್ತೆ. ಇನ್ನು ಯಾವುದು, ಇನ್ನು ಇವಾಗ ಇದಕ್ಕಿಷ್ಟು 20 hours ಬೇಕಾ? ಇಂಟ್ರಡಕ್ಷನ್ ಟು ಕ್ಲೌಡ್, ಓಪನ್ ಅಜೂರ್ ಅಕೌಂಟ್ ಆ್ಯಂಡ್ ಅಜೂರ್ ವರ್ಚುವಲ್ ಮಿಷನ್ಸ್ ಲರ್ನಿಂಗ್. Demo on available set explains the private, public and hybrid cloud. Understand different app service, plain and demo on the slots and swapping. Scale out settings, Azure basics idu. Scale settings, auto scale settings. Understand the instrumentation, telemetry, profiling, debugging, tracking, monitoring, cost of applications, inside open telemetry, implementation, track class, logging, correlated telemetry. Okay, signal or based learning ಹೆಂಗಪ್ಪ. ಸೊ ಇದೆಲ್ಲ ಯಾವಾಗ ಕಂಪ್ಲೀಟ್ ಮಾಡೋದು? ಡೇಟಾ ಫ್ಯಾಕ್ಟ್ರಿ, ಸಿಂಪಲ್ ಡೆಮೋ, ಬಿಲ್ಡಿಂಗ್ ಪೈಪ್ಲೈನ್ಸ್, ಡೇಟಾ ಫ್ಲೋಸ್ ಎಲ್ಲ ಟೋಟಲ್ಲು 53 ಅವರ್ಸ್ ಬೇಕು ಇದನ್ನೆಲ್ಲ ಕಂಪ್ಲೀಟ್ ಮಾಡೋದಕ್ಕೆ. ಅಂದರೆ ಮತ್ತೆ ಮೈಕ್ರೋ ಸರ್ವಿಸ್ ಆರ್ಕಿಟೆಕ್ಚರ್ ಬೇರೆ ಇದೆ ಇದರಲ್ಲಿ. ಮೈಕ್ರೋ ಸರ್ವಿಸ್ ಟ್ರೈನಿಂಗು, ಸ್ಟ್ರಾಟಜಿ, ಪ್ಯಾಟ್ರನ್ನು, ಆಮೇಲೆ ಹೌ ಮೈಕ್ರೋ ಸರ್ವಿಸ್ ಹ್ಯಾಂಡಲ್ಸ್ ದಿ ವ್ಯಾಲ್ಯೂ ಆಬ್ಜೆಕ್ಟ್, ಇಮ್ಯೂಟಬಲ್, ಕೊಲಿಷನ್, ಅಗ್ರಿಗೇಟರ್, ರೂಟ್, ರೆಕಾರ್ಡ್ಸ್ ಫ್ಯಾಕ್ಟ್ರಿ, CQRS ಕಮಾಂಡ್ ಹ್ಯಾಂಡ್ಲರ್, ಮೀಡಿಯೇಟರ್ ಪ್ಯಾಟ್ರನ್ಸು, ಕ್ವೆರಿ ಹ್ಯಾಂಡ್ಲರು, ಕಮಾಂಡ್ ಹ್ಯಾಂಡ್ಲರ್ ಹ್ಯಾಂಡಲ್ಸ್ ದಿ ಇನ್ವೇರಿಯನ್ಸ್. ಸೊ ಮೆನಿ ಥಿಂಗ್ಸ್. RabbitMQ, ಕಾಫ್ಕಾನು ಯೂಸ್ ಮಾಡ್ಬೋದು. AMQ, ಬ್ರೋಕರ್ ಎಕ್ಸ್ಚೇಂಜ್. ರೆಸಿಲೆನ್ಸಿ ಯೂಸಿಂಗ್ ಪಾಲಿ. API gateway pattern using Ocelot. Moving from console ASP.NET MVC. Applying security by using OpenID, OAuth, Codeflow. ಆಮೇಲೆ integrity MVC with NQ mechanisms. Covering two important concepts that from the backbone of microservices. ಇನ್ನೊಂದೇನು ಅದೆಲ್ಲ ರಿವಿಷನ್ ಮಾಡಿಕೊಂಡ್ರೆ ಇದು ಮುಗಿಯುತ್ತೆ. ಆಮೇಲೆ ರಿಯಾಕ್ಟ್ ಬೇರೆ ಇದೆ. ರಿಯಾಕ್ಟಲ್ಲೂ ಎಷ್ಟಿದೆ, ರಿಯಾಕ್ಟ್ ಓದಬೇಕಂದ್ರೆ ಇಂಟ್ರೊಡಕ್ಷನ್ನು ಫಸ್ಟು ರಿಯಾಕ್ಟ್ ಬಗ್ಗೆ ತಿಳ್ಕೊಂಡು ಆಮೇಲೆ ES6 ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಎಲ್ಲ ಕ್ರಿಯೇಟ್ ಮಾಡಿಕೊಂಡು ಇಷ್ಟು ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಎಲ್ಲ ಪ್ರಿಪೇರ್ ಆದರೆ ಇಂಟರ್ವ್ಯೂ ಅಟೆಂಡ್ ಮಾಡೋದಕ್ಕೆ ರೆಡಿ ಆಗಿದೆ ಅಂತ ಅರ್ಥ. ಇನ್ನು ರಿಯಾಕ್ಟ್ ಒಂದು, .NET ಒಂದು, ಅಜೂರ್ ಒಂದು, ಮೈಕ್ರೋ ಸರ್ವಿಸಸ್ಸು. ಫಸ್ಟು ಮೈಕ್ರೋ ಸರ್ವಿಸಸ್ ಓದ್ಕೋಬೇಕು. ಮೈಕ್ರೋ ಸರ್ವಿಸಸ್ಗೆ ಆಲ್ಮೋಸ್ಟ್ ಒಂದು 40 ಅವರ್ಸ್, 1 ವೀಕ್ ಬೇಕು ಮೈಕ್ರೋ ಸರ್ವಿಸ್ ಪ್ರಿಪರೇಷನ್ಸು. ಆಮೇಲೆ ಅಜೂರ್ ಬೇಸಿಕ್ಸು ಮತ್ತು ಸ್ವಲ್ಪ ಟ್ರೈನಿಂಗ್ ಅಟೆಂಡ್ ಮಾಡಬೇಕು. AML ರೆಸ್ಯೂಮಲ್ಲಿ ಹಾಕೋತೀನಿ ಅಂದರೆ AML ಹಾಕೋಬೇಕು. ಅದು ಬಿಟ್ಟರೆ ರಿಯಾಕ್ಟ್ JS ಅಲ್ಲೂ ಎಷ್ಟಿದೆ, ES6 ಕಾನ್ಸೆಪ್ಟು, ಪ್ರಾಜೆಕ್ಟ್ ಸ್ಟ್ರಕ್ಚರು, ಡೇಟಾ ಬೈಂಡಿಂಗ್ ಎಲ್ಲ ಇದೆ. ಡೆಮೋ, ಅದೊಂದು ಸ್ವಲ್ಪ ಡೆಮೋ ನೋಡ್ಕೋಬೇಕು. ಕಾಂಪೋನೆಂಟ್ಸ್ ಎಲ್ಲ ಹೆಂಗೆ ಬೈಂಡ್ ಆಗುತ್ತೆ, ರೌಟಿಂಗು, ಲೇಝಿ ಲೋಡಿಂಗು, ಆಮೇಲೆ ಇಮ್ಯೂಟಬಲ್ ಆಬ್ಜೆಕ್ಟ್ಸು, ಆಮೇಲೆ ಯಾವುದು ಕನ್ಸ್ಯೂಮಿಂಗ್ ವೆಬ್ APIಸು. API ಪಾರ್ಟು .NET ವೆಬ್ APIs ಒಂದು ಸ್ವಲ್ಪ ಓದ್ಕೋಬೇಕು ಇಂಟರ್ವ್ಯೂಸ್ಗೆ. ಆಮೇಲೆ ಎಲಿಮೆಂಟ್ರಿ ಪ್ರಾಪ್ ಡ್ರಿಲ್ಲಿಂಗ್, ಕಾಂಟೆಕ್ಸ್ಟು, ಫಂಕ್ಷನಲ್ ಕಾಂಪೊನೆಂಟು, ಕ್ಲಾಸ್ ಕಾಂಪೊನೆಂಟ್ಸ್, ಫಂಕ್ಷನಲ್ ಟೈಪ್ ಸ್ಕ್ರಿಪ್ಟ್ಸ್ ಕಾಂಪೊನೆಂಟ್ಸ್, ಇಂಪ್ಲಿಮೆಂಟೇಷನ್ ಆಫ್ ರಿಡಕ್ಸು ವಿತ್ ರಿಯಾಕ್ಟ್ ಜೊತೆ ಹೆಂಗೆ ಮಾಡೋದು, ರಿಡಕ್ಸ್ ಇಂಪ್ಲಿಮೆಂಟೇಷನ್ ಕಲಿಬೇಕು. JWT ಟೋಕನ್ ಅಥೆಂಟಿಕೇಷನ್ ಆಥರೈಸೇಷನ್ ಮೆಕ್ಯಾನಿಸಮ್ಸು. ಆಮೇಲೆ ಅದು ಬಿಟ್ಟರೆ ನೆಕ್ಸ್ಟು ಡಿಸೈನ್ ಪ್ಯಾಟ್ರನ್ಸನ್ನು ಕಲ್ತ್ಕೋಬೇಕಾಗತ್ತೆ. ಇಷ್ಟು ಆರ್ಕಿಟೆಕ್ಟ್ ರೋಲಿಗೆ ಇಷ್ಟು ಎಲ್ಲ ಕಲ್ತ್ಕೋಬೇಕು. ಇದೆಲ್ಲ ಕಲ್ತ್ಕೊಂಡು ಇಂಟರ್ವ್ಯೂ ಅಟೆಂಡ್ ಮಾಡೋ ಅಷ್ಟೊತ್ತಿಗೆ ಎಷ್ಟು ಟೈಮ್ ಬೇಕಾಗುತ್ತೋ. ಡಿಸೈನ್ ಪ್ಯಾಟ್ರನ್ ಆ್ಯಂಡ್ ಆರ್ಕಿಟೆಕ್ಚರಲ್ ಪ್ಯಾಟ್ರನ್ನು, ಊಪ್ಸು, ಸಾಲಿಡ್ ಪ್ರಿನ್ಸಿಪಲ್ಸ್ ಎಲ್ಲ, ಡಿಪೆಂಡೆನ್ಸಿ ಇನ್ವರ್ಷನ್ ಪ್ರಿನ್ಸಿಪಲ್ಸು, ಇನ್ವರ್ಷನ್ ಆಫ್ ಕಂಟ್ರೋಲು. ಸೊ ಆಮೇಲೆ ಡಿಪೆಂಡೆನ್ಸಿ ಇಂಜೆಕ್ಷನು ಮತ್ತು IOC ಎಲ್ಲ ಇಂಪಾರ್ಟೆಂಟು. ಆಮೇಲೆ ಪ್ಯಾಟ್ರನ್ಸು, ಬ್ರಿಡ್ಜ್ ಪ್ಯಾಟ್ರನ್ನು, ಅಗ್ರಿಗೇಟರ್ ಪ್ಯಾಟ್ರನ್ನು, ಡೆಕೋರೇಟಿವ್ ಪ್ಯಾಟ್ರನ್ನು. ಅದಾದಮೇಲೆ ರೆಪೋಸಿಟ್ರಿ ಪ್ಯಾಟ್ರನ್, ಅದೆಲ್ಲ ಕಾಮನ್ ಆಗಿ ಎಲ್ಲ ಕಡೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಸ್ವಲ್ಪ ಬೇಸಿಕ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ತಿಳ್ಕೊಬೇಕು. CQRS ಅಂದ್ರೇನು, ಕಮಾಂಡ್ ಲೈನು, DTOs ಎಲ್ಲ ಹೇಗೆ ವರ್ಕ್ ಆಗುತ್ತೆ, ಕಮಾಂಡ್ ವರ್ಸಸ್ಸು ಕಮಾಂಡ್ ಕ್ಲಾಸಸ್ ಎಲ್ಲ ಹೇಗಿದೆ. ಆಮೇಲೆ ಅಡ್ವಾನ್ಸ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಬಂದು CQRSಸು, ಈವೆಂಟು ಮತ್ತು ಸ್ಟೋರ್ ಎಲ್ಲ ಹೇಗೆ ಮಾಡ್ತೀವಿ ಅಂತ. ಆಮೇಲೆ CQRS ಸ್ಟ್ರಕ್ಚರು, ಆಮೇಲೆ CQRS ಸ್ಟ್ರಕ್ಚರ್ ಯೂಸಿಂಗ್ ಡಿಪೆಂಡೆನ್ಸಿ, ಆಟೋ ಮ್ಯಾಪರು, ಮಿಡಿಯೇಟರ್ ಅವೆಲ್ಲ ಹೇಗೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಅಂತ, ಟೆಂಪ್ಲೇಟ್ ಪ್ಯಾಟ್ರನ್ನು, ಡೆಕೋರೇಟರು, ಅಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಪ್ಯಾಟ್ರನ್ನು, ಆಮೇಲೆ ಪ್ಲಗ್ಗಿನ್ಸು, ಪ್ಲಗ್ಗಿನ್ ಆ್ಯಂಡ್ ಪ್ಲೇಸು, ಡೆಕೋರೇಟರು, ಡಿಸೈನ್ ಪ್ಯಾಟ್ರನ್ ಟ್ರೈನಿಂಗು ಎಲ್ಲ ಮುಗಿಸಿದ್ರೆ AWS MVC ಕೋರ್ ಬಗ್ಗೆ ಒಂದು ಸ್ವಲ್ಪ ಇದೆ. ಎಷ್ಟು ತಿಳ್ಕೊಂಡ್ರೆ ಇಂಟರ್ವ್ಯೂಗೆ ರೆಡಿ ಆಗ್ತಾ ಇದ್ದೀವಿ ಅಂತ. ಓಕೆ ಫೈನ್, ಐ ಸ್ಟಾಪ್ ದೀಸ್ ನೌ.